Here is a puzzle that I think will give any computer a run for its money. We have a grid consisting of 49 squares and 10 characters displayed around it, 2 of each kind. For example, at the top we have Argo1 and at the bottom Argo2. The idea is to connect Argo1 to Argo2, Dov1 to Dov2 and so on. Something like this. However, there are 2 basic rules that we follow. The first rule is that you can't use a diagonal line to connect one character to the other. For example, Dov1 to Dov2 on the screen has a diagonal line, not allowed, and Clar1 to Clar2, not allowed. The second rule is that you can't have lines intersecting. That means lines are not allowed to cross over each other. I've shown the positions where they cross by little circles, so not allowed. So this is not a solution to the problem. Let's see if we can get a start on it. There's a path that's valid for Argo1. Here's one for Blob1 to Blob2 and one connecting Clar1 to Clar2. Can we go further? I've used computer modelling to use the brute force approach to solving this problem. I've instructed it to try different combinations until it finds one that works. Now, I've been successful up to joining 3 pairs of twins, but it hasn't worked for 4 or 5. We'll look at the reason for that now. Let's get an upper bound for how long it would take for the computer to solve the problem. At each point, there are 3 choices to move. And we know there are 49 spaces or squares that each twin can go to. So that means there are 3 to the power of 49 directions. For 5 people, this is a staggering number, as you can see there, in terms of direction. Now let's suppose a computer can typically make 5 billion calculations per second. That means the maximum time would be that number divided by 5 billion, which is another very large number of seconds, as you can see there on the screen. Converting that to years, now you can see why the computer is having a hard time of it working out the solution. The chance that it would reach the right combination is very remote. But it can be done, and I'll show you the solution in a moment. That means we can actually beat the computer at its own game.